Hello everyone, I trust you are all as well as can be. Welcome to Frontline Systems webinar on optimization using the power of Analytic Solver plus RASON. My name is Dr. Sima Maliki and I'm happy to present this webinar. Thank you for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline Systems software offers to build and test your optimization models and deploy and manage your models as cloud services. The presentation usually takes about 45 to 60 minutes. You are welcome to email your questions to consulting@solver.com. Again, it is consulting@solver.com. And we try to get back to you as soon as possible. Thank you for your collaboration. Here is the plan for today's webinar. We are going to focus on mathematical optimization using Analytic Solver Desktop and Cloud. We will talk about RASON, which is Frontline Systems Cloud Platform. First, we are going to model and solve a portfolio optimization application and then utilize parametric optimization to find the efficient frontier. And as time allows, I will overview a few other classical optimization applications. Developing and testing an analytic model in Excel is just the first step. To gain the real business value, you need to get the results of your models into the hands of people who need to use those results, and doing so in an ongoing basis. People in operations, sales, customer service, manufacturing, in a form that they can easily ensure it is up to date. They can read on the model, optimization model, or data mining process, or view the results, plug them into another software, application, or process. We call this model deployment. So we are going to talk about RASON. As I said, it's our cloud platform for model deployment. And I will show you how only with a few clicks, we can deploy our optimization model to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON power. As time allows, we will talk a little bit about how to make your model results available to people using Teams, Cloud, Power BI, Tableau, or your own application on the web, and make results conveniently available to other people. Two key components to our product line are Analytic Solver, which is our authoring tool, working either in Excel desktop or Excel for the web. You just need one license and you can access both. So you can log into one to desktop license, or you can log into and use the Analytic Solver for the web. And the other one is RASON, which is our decision management platform. Almost always used from the web as a cloud hosted or Azure hosted system that offers a REST API. When we get more familiar with RASON and Analytic Solver working together, how that dynamic is today. So what is pictured here in the right side is RASON.com, which is actually a front-end portal to the REST API that allows you to do a lot of things, including building and solving not only simple models, simple optimization or simulation models, but multi-stage flows where data and model results can flow from one stage to another. And actually a picture of it is depicted here. So let me highlight for you. So this could be an optimization model. The result of optimization model are feeding to a simulation model and much more. So it's called a multi-stage flow. Analytic Solver also can be used to create and test models all by itself. But the other good news is that it's possible to deploy models to the cloud, to RASON, entirely within Excel, and even check runs of models without leaving Excel. And I'm going to show you that today. So let's open Analytic Solver for a quick overview of the ribbon. So here's Analytic Solver ribbon. I'm going to start for a quick with a quick overview. So this is the most recent version of Analytic Solver that was released on July 30th. So let's walk through the tabs. I'm going to start on top left and I'm going to erase all the drawings. So top left, right there, the model tab. So clicking on the model tab displays or hides the task pane. As you can see, the task pane it appears, and then as I click, it disappears. In the model dropdown, you have access to multi-dimensional modeling, which is available in Analytic Solver Desktop and Analytic Solver Cloud. So this tool is very helpful when you are building larger models where there are multiple products, projects, investments, time periods, multiple sources, destinations, and dimensional modeling can help you turn a very complex, hard to maintain spreadsheet problem into a simple, well-structured, easily maintained, and expandable model. It works great with pivot tables. So if you're interested, feel free to explore the user guide. There's a chapter on multidimensional modeling, but it's beyond the time that we have today to cover the multidimensional modeling. And email me if you have any questions at consulting@solver.com. Next group of options are simulation models. So here you can click on distributions button to access a range of predefined probability distributions or correlation. So you can have common distributions, advanced, exotic, discrete distributions, and custom distributions. So next, you can induce correlations among uncertain variables, and you use results button to calculate the statistics, risk measures, range values, and much more. So we cover most of this in the upcoming webinar. Next group is the optimization model group. So you can see that we have the three main components of optimization problems: decisions, constraints, and objective. So everything you need to set up your optimization models. So decision variables available as normal and recourse forms, constraints, normal constraints, chance constraints. Normal constraints is like A should be less than B 100% of time, but chance constraint is when you have A should be less than B 95% of time. This is when you have risk and uncertainty in the optimization model. So Analytic Solver enables you to not only model and solve deterministic optimization problem, but also you can model and solve stochastic optimization problems. And then you have variable type bound, so you can define variables that are integer, whole numbers, binary, they take only 0 and 1 values. For example, you solve a problem deciding if you have to open a company in this new location versus not opening it. So it's a yes, no type decision. You can use binary decision variables. They are also very useful when you are trying to linearize optimization model. For example, you want to define an if function, but you can use a binary decision variable to avoid a function which will change the structure of your optimization model and keep the model linear. We will talk more about that as time allows. Next is decision model group. So you have access to DMN, business rules and decision tables. We are following DMN standard. So Analytic Solver supports decision trees, decision tables, and box function. Next, here on the parameters, you can define multiple parameterized optimization and simulations, solve simulation models, solve optimization models, and next is deploy model icon. So let's talk more about deploy model icon. Let's click on deploy model icon, and here your optimization or simulation model can be deployed to teams as a cloud service, packed for Power BI or Tableau, your own application, and on your own web application. And you can make the results conveniently available to other people. So the purpose of deploy model is to enable your model to be used wherever, whenever it is needed, on the factory floor, on a salesperson's laptop or smartphone, in a call center, custom application, and much more. And we're going to practice that together. So let me close this for now. Next, you have different get data that allows you to bring data into Excel, and then you have different options for optimization and simulations. You can click on license to get your license status, get on help to access user guides, example models. So for optimization examples, we have examples that are available for production, finance, logistic, purchasing, scheduling, and much more. So if you're starting to build your first optimization model, this would be a great place to start. Also from help, if you click on education and training, you can access Solver Academy that offers you advanced courses on optimization and simulation using our products. Now let's quickly look at task pane on the right side. So I'm just going to click on model tab. This is task pane. So model tab allows you to view the model in an outline form and optionally edit model elements in place. So if you open the optimization, if you have variables, objective, and constraints, you can see them under this under optimization. Platform tab is next. This gives you lots of options for optimization and simulation models, and you can see that the first option is number of optimizations to run. So once we practice a parametric optimization, you'll see that I will change this option. Next is engine tab. You have 5 built-in solver engines, and you also have additional add-on engines. For example, one of the building solver engines is its evolutionary engine, which uses a variety of methods, including genetic algorithm and Tableau search. You have access to interval global solver engine that uses interval methods for deterministic global optimization. And you also have solver engines that are commercial products. For example, Groby solver engine, powerful high performance Nitro solver engine, excellent high performance engine for smooth nonlinear optimization problems. So for any type of optimization problem, for any structure, linear, nonlinear, mixed integer, non-smooth, you have an engine that can solve that type of optimization. And you have the standard engine and the additional ones if you're interested. Output tab gives you a report of what has happened. Workflow is relevant to data mining, so we will cover that in data mining. And then Tools tab allows you to cycle through individual optimization, for example, when you run multiple parameterized optimization. And we will come back to Tools tab later. Okay, so I'm going to open our first optimization example. So 1 second. So now we are ready to practice and build our first optimization problem. I have already went ahead and created all the formulas in this optimization problem. So we are just going to practice building it together, okay? This is a financial services application allocating money to stocks. So here is the story. An investor wants to target a specific rate of return for his portfolio while minimizing risk. So this is a portfolio optimization application. Our goal is to find the best combination of stocks that minimizes risk for a given return. So as you can see, I have return, variance, and covariance between all stocks that are known, and I have them here. So I've already organized the data and created the formulas on the spreadsheet. So what are the variables in this optimization problem? Variables are the percentage allocations of funds that we can invest in each stock. So we can define the decision variables by selecting this block of cells. So I'm going to first replace them with all the zeros to make it more clear. So here are all the zeros. You select this block. So I have one cell for each stock. So we have stake 1 to 5. I select this block of decision variables. And to define them, just go to the ribbon on the top and click on decisions and normal. As soon as I do that, you can see that on the task pane, I have allocations. This is a name range that we use. You can. So I selected the range and defined the decision variables. Now let's define our objective. Our objective is portfolio variance. So I can calculate that here. I have a portfolio variance. In cell C22, I'm using a quadratic function to calculate the portfolio variance. And you can select the cell and then go to, let me skip from formula. So select the cell, go to objective, and then we can go to min, normal to minimize this cell and define it as our objective function. So now you can look to the right in the task pane, you can see that portfolio variance, which is again a name range for this cell C22, is defined our objective. So this is our normal objective to be minimized. Now, what kind of constraints do we have? Our first constraint is total portfolio. So we want to make sure, we want to sum all the allocations of funds of two stocks, and we sum it to 100% or 1. So you need to set up one cell in the spreadsheet to represent the formula of the constraint. And here I have this cell, H18. You can see it's a sum of all the portfolio percentages or all the decision variables. So let's select the cell, go to these constraints, normal constraints, and we want to make sure this equals or it is greater than or equal to 100%, or you can also enter 1 on the right hand side. So let's enter 1. Okay, now on task bay we have total portfolio equals 1. Next, our second constraint is total portfolio return, which is our sum product of allocations and stock returns, and we need to tell Analytic Solver it should be greater than 9.5%. So let's select a cell. I have one cell that calculates the portfolio return, and you can see that it's a sum product function. The first array is portfolio percentages, and then second one is the expected return. It's like multiplying everything together. And then we have to tell Analytic Solver, this is our left hand side. So let's go to constraint, normal constraint. It should be greater than or equal to, and on the right hand side we can enter 9.5% and click OK. Now you can look to the right and you can see that all of our constraints are defined. Portfolio return greater than 9.5% and total portfolio equals 1. Okay, now we are ready. Let's go ahead and click on Optimize to solve the optimization problem. This time, we are going to step through guided mode. Guided mode is a feature that's designed to help us. It can understand the model, analyze the model, find out what is the structure, and help us choose the correct engine. And if there are any problems, it can identify the problem. Let's click on Continue. So the model was diagnosed as QP or Quadratic Programming Convex. And as soon as I click on Next Step, we get the results. Solver found the optimal solution, and all the constraints and optimality conditions are satisfied. So let's click OK. The workbook gets updated. Here are the results. So this is the allocations of fund to different stocks, resulting in the minimum risk or minimum variance portfolio that achieves at least a 9.5% return. So in the right hand side, you can see the task pane. We got a summary report. The optimization is solved, and with the standard LP quadratic engine. And there's this green hyperlink. You can always click on the hyperlink and it brings the Analytic Solver help for you. This is often called an efficient portfolio. You may also have heard of efficient frontier. So using our products, you can easily construct the efficient frontier and I want to show you how you're going to use the power of parametric optimization. So let's first define a parameter. So far in our example, we have used the solver. We have found the optimal portfolio with minimum variance for a given target rate of return of 9.5%. And we are going to generalize that. Basically, we want to utilize parametric optimization to find the efficient frontier that is the optimal solution for several levels of portfolio return. To do that, let's define an empty cell, okay? And I'm going to define it, insert a parameter, okay? So select the empty cell, go to parameters on the ribbon, sorry about that, Analytic Solver parameters, and go to optimization. So let's click on parameter. We are going to enter the lower level and upper level. You are also welcome to enter different values that you want to test for your parameter. So for the lower level, I'm going to put 8% for the return. And on the upper, I'm going to choose 14%. As one of our stock returns 14%. So you can see it's a stock 5. Let's click OK, and you will see that on the formula bar, psi opt param between 8% and 14% is inserted here. So far, we have defined the parameter. So we have a psi opt param between 8% and 14% for the return. Now we have to use this parameter in the optimization model. So let's double click on the portfolio return constraint. And instead of the constant value of 9.5%, we have to use the parametric return value. So let's click on this button and point to where the parametric return cell is. So it's in E24. And as soon as I click OK, our portfolio return constraint is updated. Now we have to change how many optimizations we want to run. So to do that, let's go to Platform tab. This is the first option, is number of optimization to run. You can change it to 10. This will tell Analytic Solver to run one optimization for the return value of 8%. One optimization, the last one would be 14%, and then the 8 other optimization would be with the intervals between 8 and 14, equal intervals, okay? But if you want to use a specific values and a specific number of optimization, you can do that. So now that we're ready, we can click on Optimize on the ribbon. And I'm going to skip guidance. We already know the structure of this optimization. Our engine selection, a standard LP quadratic can solve that optimization. So let's skip guidance, and it's going to solve all the optimizations, and here are the results. So you can see on the task pane, output tab, this is optimization number 1, all the way to 3, all the way to 10, okay? And we can look at the individual results for each of the optimization. Remember, we talked about the tools tab in the task pane. So this is optimization, last optimization, optimization number 10. You can see the return on the workbook is 14%. And this is the portfolio. So this is the values for the last optimization. But with the tools tab, you can display any of the optimization results. So let's change the selection for optimization number. So it's the second one right there. And then I can change it. This is optimization 10. You can change it to optimization 1. Let's verify return is 8%. And then, for example, we can look at optimization number 5. The return is 10.67%. Now we can also look at some of the charts. So let's go to charts, and you can look at multiple optimization, monitored cells, and let's look at objective. So our objective portfolio variance, move it to the right, portfolio variance, and click OK. So here are the results. So we reviewed how to model and solve a business problem in Excel using Analytic Solver. So I want to spend some time on deployment, and as time allows, we can look at some other examples, okay? So let's see how we can promote this optimization model that we built in Excel, and also we created parametric optimization from it. and we want to promote it to be able to run it on RASON Cloud Service and make it available to other people. So this is about the idea of sharing your model with other users. So we are going to do this by using by use of a cloud service. Okay, so let's click on deploy model on the ribbon. I'm going to skip Teams for today. Let's click on cloud service. Just before that, if you are not sure what to do and this is the first time you are using deploy model icon and you want to check this, use this feature, you can use Deployment Wizard. Okay, so Deployment Wizard can help you guide through the menu options. So let's click on Deployment Wizard and you can click on Next, and you can see that it will help you choose what you want to do with your model. So first option, I'm completely new. What is RASON? Can you show me a quick test? Next one, I want to share my model results in Teams, or I want to run it as a cloud service. And then you click on next and it gives you more information and so forth. So that's a very good start. So let's go back to deploy model group now. So we have different options. These allow our optimization or simulation model to be deployed in the cloud, packed for Power BI or Tableau, or your own application on the way. And I'm going to try to show you a few examples. So let's click on cloud service first. Let's promote our model to RASON server. So cloud service, basically creating a cloud service from our model. There are two ways to do this. The first one is Excel model option. And this option makes things very simple. So let's click on Excel group, Excel model, and we need to give our model a name. So by giving it a name, and remember, you can actually, your model can reside on OneDrive. So let's give a model a name and just keep the default name for it and click on save. Just ignore that. So this action will save our model, the Excel workbook itself, to the Azure cloud and saves a copy of your workbook in your account in RASON Cloud Service. Okay. As soon as I did that, you can see that RASON.com opened up. Okay. Immediately, model is displayed without any translation into RASON language. Okay. So by doing this, our model, our Excel workbook itself is posted to RASON server, and we just see a copy of the workbook here. And actually, it's just not one of them; it's all of it. Look at it. It's Markowitz webinar. Everything that was in that workbook, Excel, all the tabs of Excel workbook, all are present here. So you can see that, you can appreciate this is exactly the Excel workbook itself, but we can see a copy of it here. Okay. So what is this? We are in RASON.com, okay, the editor page, or we also call it the web IDE. So let's learn and see what we have here. We're going to navigate to RASON.com. RASON.com is a front-end portal, and in the backend, there's a REST API service that can be used by any application. So basically, what you see here, RASON.com itself, is an application, okay, that uses the backend service at RASON.net. That is where the actual server is, which exposes a REST API and allows any other application to perform optimization, simulation, fit a trained model, invoke a trained model to score new data, and much more. Okay, so by starting from Excel, we post the model to RASON server, okay, and we see a copy of it in the front end portal, which is RASON.com. This is basically something that we created for your convenience, so you can access your model, see what's happening, what kind of communication you need to work with the server, and take some action. For example, solve the model, get the results, and much more. So let's get more familiar with RASON.com. So this is the model editor. We have the model right here. Okay, this is the editor, the model part. Okay, so we can see the model right here. Down here, it's the output section. Okay, so here we can see that what is the kind of communication that's happening to get a model and displayed here on RASON.com. Here we are using get HTTPS, RASON.net, and much more. Okay, the name of model. On the left hand side, these are all the models I have under my account. Okay, so this is under CMOS account on RASON server. These are all the models that I have posted to RASON or created in RASON. On the right hand side, you have different properties for each model. You get to see the properties. And to make it very simple, on the top, you have some execution option. You can access examples and much more. So let's just go ahead and post and solve this optimization problem. So you can click on optimize and the results will be available in JSON syntax, or you can click on solve and the results will be available in two ways. So I'm going to click on solve to show you how the results will be available. So the model will be loaded, parsed, diagnosed, and solved on RASON server, and the results will be made available to you where we made the request, right? So we are asking for the results here. If you look down to the output section, you can see that with some messages, some queries were requesting the results to be displayed here. And the results are now available. This is called OData format. So let me show you. Let's look at the decision variable C18 to G18. And you can see that these are the final decision variable values. But remember, we posted the parametric optimization. So these are optimization 1 results, optimization 2, all the way to optimization number 10. You can appreciate the speed and everything is available. And final variable values. This is OData format, and here on the right side, you can click on show JSON results, and results will be available in JSON syntax, okay, for all the optimizations. So let's go back to show OData result, and let me show you the final objective. Here are the optimization index and final objective values. Okay. So depending on what optimization, I have different tabs, so I can solve this one, Markowitz, efficient frontier, and much more, but we are solving this one. Okay, let's go back to Excel and try something different. This time, we are going to translate the whole model into RASON modeling language, okay? Let's click on Deploy Model, Cloud Service, RASON name, Stock Portfolio Optimization Webinar, and click on Save. So during this time, the whole model will be translated into JSON syntax, okay? So here is the model, the results are available, okay? Decision variables, constraints, and objective. It will just it will only post the active worksheet in this status when you do the RASON. So this is in JSON syntax. Similarly, you can go ahead, post solve, and solve the model and get the results. Loads the model, parse, diagnose on the RASON server, and the results for this optimization. Again, this is 10 optimizations, so we get all the results available for decision variables and for objective. And again, you can switch between JSON syntax or OData. So we saw how automatically the whole Excel model was translated into JSON syntax. So this is the JSON syntax, the model with the variables, data, and much more. So far, we built our optimization model in Excel using Analytic Solver, and then we learned how to deploy the model. We practiced two approaches. We promoted the Excel model itself as is in Excel file form, and then we also deployed the use the deploy app and translate the Excel formula and all the data in the model to equivalent expressions and data in a RASON modeling language in JSON or JavaScript object notation without any need for you to do any programming. Everything was done automatically for you. Okay, so now let's go back to Excel. And I want to show you one more thing. Let's go to Deploy Model Group. Let's click on Manage Models. Here, all your models and versions of your models on your account on RASON.com are displayed exactly same way. So everything on my RASON server account on server RASON.net displayed here, and you saw the same thing on RASON.com, right? So all the models are available. I can look at different versions of them, okay? If they have different versions, you have them, and you can check the runs and delete the additional. And you can appreciate how RASON and Analytic Solver are tightly integrated together. As soon as I select a model, I can see all the runs, and then I can delete them. Okay, so back to our Markowitz portfolio optimization model that we have. We created parametric optimization from it. And remember at the beginning, I showed you that I want to show you one example of going beyond what you can do in Excel and create your own web application. Okay, so this is pretty straightforward. Let's click on deploy model option on the ribbon, and then click on quick test. And you can see that there's an option here called web page. Okay, so let's click on web page. And within a few seconds, you will see that this HTML web page created for us. This section, it has a template that's shipped with our product, so you can actually change the template, use the same one as a basis for your web application, okay? And this HTML page uses simple JavaScript, and you can see that in this part is the entire optimization model. We have the query parameter, and down here there are some endpoints that we can make AJAX calls to solve a model, quick solve it, stop, and get clear messages. Okay, some actions that we can take. And so let's click on solve and see what happens. So basically now we are connecting to RASON server, and we're solving the model. And remember, this was a parametric optimization, so I just finished solving 10 optimization on RASON server, and the results are back available to us. So if you right click here and look at view source, you can see that in this standalone web page, you can see that we are using HTML to define edit fields and buttons. We have JavaScript to run and solve the flow of the model by making REST API calls to RASON server, and everything you need to run the entire model is available in this single page. And this is something you can use, the developer can use for building your first mobile or web application. And the good news is also that when you go to RASON.com, here's the model, right? We have the model here, and there is an option here that creates an app from the RASON.com page. So let's go to create app, web page. Similarly, it downloads the RASON script, HTML page, exactly what we saw in Excel. It's just a little larger, zoomed in, and I can click on solve and solve this, make AJAX call to RASON server and get the results back here. Okay, I hope this was helpful. So let's go back to our slides for a summary of what we learned today. I wanted to show you a Power BI example, but we're running out of time. In the next series of optimization webinars, but after October 15, I will show more of Power BI and Tableau. So let's go back to our slides. And I want to This is just a summary of what we learned today. We started with Excel, we deployed our model, created cloud services, and we used two different methods. We actually used a posted Excel workbook itself, or we created RASON version of our model in the RASON language, right, JSON syntax, and we promoted our Excel model to sit on RASON server, and now it is available to any other application. And I showed you how you can how we can create a web application and access RASON server and get the results back in the web application. And RASON.com was another application itself that shows us and makes it very simple for us to communicate with RASON server and post the model, get the results, and get the results with different formats, or data and JSON, and much more. Okay, we practice this together. Of course, Excel makes it easier to getting started with analytics. And good news is Analytic Solver Desktop works with Excel, and Analytic Solver Cloud works with Excel for the web, and both of them offer all the tools that you need to work with deterministic optimization, Monte Carlo simulation, large scale conventional and stochastic optimization, DM and fin compatible rules and decision table. And while we are here, I want to quickly show you. So I'm going to pause the screen 1 second to show you. Let me see if I can access my Office 365. Let's open an Excel online. So here is Excel online. I'm using Office 365. So this is a blank workbook. I just want to show you Analytic Solver cloud version. There it is. And you can see the ribbon is very similar to what we practiced and saw in desktop Excel. Okay, so you can access and use it from the convenience of your browser, all of this power. And as we saw today, the two key components to our product line, Analytic Solver authoring tool, and working in two ways with the desktop Excel or Excel for the web, and RASON that very easily combines the power of predictive and prescriptive analytics for you and allows you for you to make the results of analytic models, to share them very easily and drive your operational decisions and actions. Okay, and it supports that by supporting rules, decision tables, and allowing you to expose analytic model results in both JSON and OData. And these two can be consumed by lots of software directly. Okay, and our products work really well, in particular with Microsoft Power Apps, Power BI, and Microsoft Teams. Okay, you can create data connections very easily with RASON. There is much more to RASON, and this is a screenshot showing the multi-stage decision flow in RASON, the diagram editor. We didn't get a chance to go over that today. That's a webinar by itself, going more in depth with RASON. And the diagram editor in RASON can be used as a drag and drop tool to create multi-stage flows. And you can go back and forth between RASON modeling language, what we saw today, and the diagram view. So the next best step would be to, if you are new to our products, download a free trial, check out the example models, explore RASON.com, and download your free trial of Analytic Solver. If you have any questions, email me at consulting@solver.com. That's the best way to reach out. And you can also contact us for tech support using live chat or call this number. Remember that if you are an existing customer, we have a customer success team that is fully dedicated making sure our existing customers are successful using our products. So please reach out, and if I will connect you with the right person. Thank you very much for your time and attention. We appreciate your time, and I trust this webinar was helpful. Have a wonderful rest of the day, and I look forward to receiving your emails and questions and connecting with you.